This is 2.3 at interpreting a histogram and constructing a histogram. So all a histogram is, are you have these rectangles where the height gives you the frequency and the width is equal to the class width. And some of them you'll see right next to each other and some you'll see with space. Some people like to call these bar graphs, but these are all histograms. The histogram below represents the weight in pounds of members of a certain high school math team. How many members are included in the histogram? Well, as I mentioned, the height is the frequency, so all I have to do is find these values and add them all up. So all I did was find the height of each bar and then simply added all of these up to get 20 total members. If you want to look at data, so here I have a frequency distribution and I want to figure out which one of these matches this data. What I do is I look right here. In the middle is going to be the most data. So I know there's no way it can be this one or that one, because this says the highest value is going to be D, which is the one in the middle. So with both of these, I have that same value. Okay, so it looks like that matches. Well, now what I'm going to look for is we're getting to the point where, and you're going to see this come up in the future, where when we build a histogram, we like to keep no spaces in between, because that means there's a gap in our data. And so this would make more sense to be the definition of a histogram, where our intervals, if you remember in the last section, we said, well, if our intervals from 1 to 2, really our interval is from 0.5 to 2.5, where we fill in the gaps here and just put our data values together. So with that being said, it would be our correct histogram.